Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillah for the opportunity for being here again and just continue on the next chapter. Before this, we have learned about oogenesis, right? For part 2 of chapter 4. And actually in female, the processes of fertilization, the cycle itself is quite is quite complex rather than in male. So before this, we have learned about oogenesis, mean the development of ovum. Now we are learning on chapter 5 for ovarian cycles. So at the end of this lecture, you should be able to understand the different stages of the ovarian cycles. So we will see what are the cycle there. Second one, to compare what is the differences between menstrual cycle versus estrous cycles. This one mainly occur in animals. Then for the third one, we should understand the hormonal changes during the cycles, what are involving, what are the hormone types and so on. And the fourth one, we should be able to understand how the ovarian cycles coordinates the events of female reproduction. So in terms of physiology of human reproductive systems, there's a lot of complex things or complex cycle, complex development, starting from the eggs itself, what we call as oogenesis, then go into the ovary itself, the cycle of ovary from maturation of follicle, the ovulation, and then development of corpus luteum. And then we do have the uterine cycle, or what we call as menstrual cycle, is that's not fertilization occur. So the series of changes that occur to the lining of the uterus for the endometrium, and this one are occurring every single month. What are happening during pregnancy, and then when do the female undergo menopause, and how that event occur. So this is an illustration for oogenesis. We do have learned before the development, including first one from mitotic division. These are occurring inside the mother's womb. Of the mitotic division from diploid oogonium will keep on dividing to produce almost 400,000 of eggs inside the womb, inside the uterine of one fetus, and then it develops into primary oocyte. But these are arrested only up to prophase 1, prophase 1 of meiosis 1. And then it is further going into puberty. After the girls undergo puberty, the completion of meiosis 1 and onset of meiosis 2 are occur. Okay, here the meiosis 2 are occurring by having or by developing into two types. First one is first polar body, and second one what we call as secondary oocyte. From primary oocyte there, okay, then it's developed into primary oocytes. Now it's going to be haploid in number, but it is also arrested in metaphase 2 of meiosis 2, and every month ovulation occur means they are released from the ovary, and then they are just waiting for any entrance of sperms into the ovum. If it's not, so you'll undergo a menstrual cycle. But if the sperms are enter, means they will further develop from metaphase. It will complete the cycle into anaphase, telophase, and developing into a complete fertilized egg, which are now deployed in number, and then cell now are growing. And we do have a second polar body. So there's a lot of hormones that are trigger the hormones that are triggering the process of this development, what we call as FSH, what we call as follicle hormone triggered FSH. So this is why the cells are growing larger than its first starting point. So we now go into the ovarian follicles, first one, the follicular stage. Okay. So I try to enlarge the illustration. Okay, this is before birth. The follicle itself, from mitosis, it is called as oogonium. So they do have primordial follicle, and the cells are static, no changes in the cells itself. But from adolescence means the onset of puberty. Primary oocytes also are unchanged until, as well as the primary follicles. After the meiosis 1 are completed, okay, so the follicle also are growing simultaneously. From primary follicles, it grow or develop into secondary follicle that do have a lot of layers, from granulosa cells, zona pellucida, as well as what we call as theca folliculi. Then they further develop into tertiary follicle, but now we can see a very distinct feature of the cells itself. Means the oocytes here can be, secondary oocyte here can be seen very clearly. And then there's a lot more of fluid there, such as antrum, cumulus, rather than theca and theca externa. Then ovulation occur means the ovulated oocytes have been passed from the ovary into the fallopian tube and so on to wait for any fertilization if it is occur. Then the bleeding into antrum, ovulation mature. Now we are called as Graafian follicle. There's a lot of follicular fluid also being released through with the ovum itself, and then the follicle now are being ruptured into corpus luteum. This is all the microscopic picture, means under the microscope you can see clearly what are happening inside there. So it's actually the follicular stage, we do have from primordial, primary, secondary, tertiary, as well as Graafian follicle. And these are starting from only 2 to 3 millimeter a day, and can reach up to this 17 to 27 millimeter. 17 means here 17 to 27 millimeter size if there's occur of ovulation. So there's a lot of layers in the granulosa cells, and then we can distinguish which part of component stages based on the presence or absence of the antrum inside. So this is the overview. Okay, so inside the ovary, there's a lot of phases that occur simultaneously. So we can distinguish which follicle are based on the layers, and then based on how's the morphology of the follicles itself. So if the follicle are mature there, this one representative of the mature follicles, they do have antrum there. Inside here, we do have antrum. This is the most distinguishable terms that can be differentiate this follicle rather than another types of follicle from primary or secondary follicles and so on. So we do have like one layer, one fluid layer there, what we call as antrum. Okay, after it is ruptured, now you can see the morphology of like some sort of ruptured motion of corpus luteum, and then now it comes corpus albicans and so on. So there are several stages of follicular genesis. The first one is primordial follicle that only has oocyte nucleus, cortex of the cells, as well as the oocyte itself. Primary follicle starting to grow of granulosa means the granulosa cells are thickening the follicle with also zona pellucida that layering the oocytes. Okay, then the secondary follicles, instead of granulosa cells, zona pellucida, we do have the thickened oocyte and nucleus are now become more visible, and then there's one field of gap here, what we call as antrum there. So this is what we call tertiary follicle with antrum inside the oocytes. And then during ovulation, now the follicle are ruptured, and then only left is only the follicle, what we call as the corpus luteum. Okay, so this is the stages of follicular genesis. Okay. One by one, for primordial follicle is only at time of the birth. It's surrounded by thin single layers of follicular epithelial cells. These are delimited for the rest of the ovarian stroma by a basal thin lamina. Means there's not a lot of layer there. Follicular epithelial cells are former coelomic epithelial cells, what we call, and primordial follicles always form majority of the follicles in the ovary. Then we do have primary follicles. Okay, this is primordial. This one focus on primary follicle. Now we can see a development of granulosa cells. Granulosa cells, which one is occurring after puberty, means after the onset of puberty, the primordial follicle will respond to signal each day, join a pool of immature growing follicles because of primary follicles. It only start from only one layer, okay, one layer of granulosa cells, but then become active and transition from flat to rounded and cuboidal cell shape that increase in size and can proliferate. So now the granulosa cells now are becoming thickened from one layer to another layer to another layer, one we call as the secondary follicles. Secondary follicles encompass from multiple rows, and then this is not called as cells of granulosa, but now it's called as stratum. Stratum means a layer of granulosum. So what we call as a layer of granulosum. Secondary follicles is mostly from glycoprotein, the pellucid zone, and this is whereby we can distinguish between oocytes. This one is oocytes, and we can distinguish between the follicular epithelium, become visible. And it is the outside there, we can see basal lamina and stroma that become thicker follicular cells. The follicle stage for the third one is tertiary follicle, and this one are the beginning of the fluid filled cavity, what we call as antral follicle, antrum. Okay, the fluid is what we call as antrum. The oocyte lies at the edge of the mound between the granulosa epithelial cells. Connective tissue differentiate itself into pica interna. Pica interna, what is for? It is supplied by the capillaries, lipid rich cells, and pica externa. It is from a transition for stroma ovarian and contains larger of the vessels. This is what we call as tertiary follicle with pica interna number 4. Yeah, pica interna. Okay. And then pica externa there with a lot of vessels. Okay. And we do have fluid filled space, what we call as antrum. And now it is possible for the oocyte to be released from these matured tertiary follicles. And then if now it can call of Ovarian follicle, we do have a well-developed antrum filled with what we call as follicularly core, and oocyte located within a hillock of multiple layers of follicle cells that projects to the internal cavity. The follicle cells directly adjacent to oocyte from corona radiata will remain associated with oocyte after ovulation. So it's a lot of tissue layers of the follicle itself, from cumulus ovorus, corona radiata. Okay, this is the cumulus ovorus, corona radiata. We do have granulosa cells, okay, that develop from the first follicular stage. theca interna as well as theca externa then. This is another illustration of the follicular space with the hormone involved. From granulosa cells, it's now developed into theca for secondary follicles. Now the follicles are reacted to hormone, what we call as follicular stimulation hormone. Follicular stimulation hormone, the hormone that stimulates the follicle itself. Then now from FSH, it's developed into antrum, liquid filled cavity, what we call. Then also from FSH, it initiate into maturation of the follicle itself into a very distinguishable oocyte itself. And then after that, luteinizing hormone LH will then the one who are responsible for ovulation to occur. And then after ovulation, the LH also will further develop the follicle into corpus luteum to be ruptured. And the luteinized cells are only becoming granulosa and theca. So these are the tissue layers of follicles with its function, mostly for cumulus ovorus. It supports the oocytes, granulosa cells, its control oogenesis and for estrogen production. For theca interna, it is a receptor for LH to produce androstenedione from acetate to cholesterol to give the granulosa the precursor for estrogen manufacturing. But after rupture, the theca interna will differentiate into theca lutein cells of the corpus luteum. And we do have corona radiata, which one for the protective layer of the ovum, and this one for supply of protein to the cells. Then this follicular genesis has only one picture, what are occurring inside the ovum, the ovary. Follicular genesis is defined by the process of follicle development, and they reach ovulatory stages, passing through stages from primordial stage, primary, secondary, tertiary, and finally pre-ovulatory of Graafian follicle stage. The peak number is from fetus at mid-gestation, and approximately we can have 7 million of it. But after birth, it's only left for 2 million, half million at puberty, 25,000 at the age of 37, and less than 1,000 during menopause. So this is a very progressive decline that affects 99% of all follicles. And now we are trying to know, now we have covered for oogenesis, then for the follicular stage. Then now we are going to learn about the uterus cycles. The development inside the uterus itself, what we call as menstrual cycle. Okay, so it is a series of events once they have only reached puberty, and it is end after they are having menopause. And the cell cycle lasts average in 1 month, not complete 30 days, but it's only for 28 days. And some of women can have from 20 for the shortest time or longest time for 40 days. And this is for fertilization, pregnancy, and so on. And there are 3 stages of menstrual cycle. From the menstrual cycle can be broken down into 3 stages. First one, follicular stage. Second, ovulation. And third one is luteal phase. So, follicular means the development of the follicle itself. Ovulation, once the secondary oocytes are released. And then the luteal phase, if the follicle been ruptured into corpus luteum. So this during follicular phase, hypothalamus release gonadotropin. This is try to capture back on chapter 3 that we have learned. Okay, gonadotropin releasing hormone, what we call as GnRH. Okay, hypothalamus inside the brain. Okay, we do have hypothalamus. Hypothalamus release GnRH. So GnRH are activating anterior pituitary, okay, anterior pituitary gland also in the brain, anterior pituitary gland also in the brain. It's like some structure there are. Okay, this one we do have anterior pituitary gland, and this stimulated to release 2 types of hormone, what we call as FSH, follicular stimulating hormone, and LH, luteinizing hormone. So I hope that you can bear in mind these 3 is directly related to the name. Follicular phase mainly can be can be dependent on this FSH, or for LH can be this LH can be directly related to this phase, between this. Then go to the first day. Okay, everyone, you should know that the cycle begins during the first day of period. During the first day of period. During the first day of period. Okay. During the first day of period, we see the uterine cycle. They are the most thickened part of it. And the level of estrogen and progesterone on constant. And then the follicular phase are just begin. The FSH also just in a beginning stage, okay, after the menses. Okay. Then after 7 to 9 day or 15 day after the menses, it is starting for the follicular stage just start to occur. From primary going into secondary and into tertiary. It is just beginning. After the mens itself is cycle occur, so the follicular stage are occurring simultaneously. Okay, the follicular stage are occur simultaneously, and they are growing there. The second one, it's undergo after the mens. The proliferative phase of the uterine means the uterine are rebuild back the uterine walls itself. So this is called as proliferative phase. So the amount of estrogen will be higher. The amount of estrogen that are released by ovary are higher. Okay. And then the FSH also will become higher and almost equal to the LH. Okay, now you can see during ovulation, it's almost after 14 days after mens. 14 days after mens. Okay. And this is the peak where ovulation occur. Okay. During the FSH as well as the LH production at the peak level of its production. Estrogen also almost there as well as inhibiting. Okay, then if there's no fertilization occur, okay, this is what we call as secretory phase. Progesterone hormone are directly increase, and LH hormone are rapidly shoot down, as well as the FSH into luteal phase. This is what we call as all the hormones that are related from G and gonadotrophin hormone, ovarian cycle, ovarian hormone level, uterine cycles, and most of the body temperature. So the phase is from follicular stage, ovulation, luteal phase. Okay, so now we are concerning about the first of pituitary, the one inside the brain itself. That's why all the women shouldn't be so stressed and so on, because if it is or stress always occurring and so on, so it can indirectly affect the hormone released by the brain itself. Okay, so you can see, try to change the color. FSH secretion is slightly greater than LH during early phase of menstrual cycle, and LH secretion is greatly exceeds FSH secretion just prior to ovulation. Means here FSH starting to have a higher level rather than LH itself. Okay. But LH will be greatly exceed FSH just prior to the ovulation. After ovulation occur, the LH will exceed the FSH level there. Okay. We do have pituitary ovarian axis that do have was controlled by the hypothalamus. There's hormonal interaction between anterior pituitary and the ovaries. Both the FSH and LH move down the ovaries. What for? To stimulate for development of immature follicle into secondary. Follicle will be developing into granulosa, and follicle will begin to release. Okay, the follicle itself also can release what we call as estrogen. And then also can initiate the thickening of endometrium. And then the rise of estrogen also can sharp rise in LH that will surge into, well, rise in LH. Okay, LH hormone. So means the sharp rise into LH itself, direct. And so it's cause for ovulation to take place. So this is controlled by negative feedback here, what we call as inhibiting. So it is overall hormonal interactions that are occur during menstrual cycles. So one by one, try to see which parts of hormone that are responsible. First, we are starting from gonadotropin releasing hormone, okay, GnRH, at the hypothalamus inside the brain. Okay, this will stimulates the release of hormone LH and FSH at the pituitary gland, anterior pituitary gland. So there's a release of FSH and LH. FSH will activate the growing follicle from primary follicle into primary, secondary, and matured follicles. And then not only FSH and LH, we do have second hormone, what we call as estrogen. Estrogen will slightly elevate in the level and rising inhibin level. Okay, means the inhibin can inhibits any other production of any stimulation. No more stimulation but into the GnRH. Okay, so this inhibin inhibits any stimulation of GnRH, so nothing will follow after this. So estrogen also, secondly, will cause a development of mature follicle. And then the high estrogen level will cause LH, LH to stimulate ovulation. That's why the LH level is increased. Surge of what is high estrogen level here can stimulate GnRH to produce more LH and FSH. That's why there's a surge in and LH and FSH. But now it's not FSH, but the one who are having a higher stage is LH hormone. Okay, rather than FSH. So then ovulation are occur. So it's only the follicle that are remain, and then it can cause a production of corpus luteum and menstruation are happening if there's no fertilization. Estrogen, progesterone, and inhibin are secreted by this corpus luteum to inhibit the give an inhibitory feedback to the gonadotropin releasing hormone. So means there a lot of hormones that are responsible. From first GnRH, second one FSH, LH, and then we do have estrogen also that released by the secondary follicle. And then we do have also inhibin and progesterone, estrogen, and inhibin also can inhibit anymore. There's no more stimulation of GnRH. So these are the hormonal interaction during menstrual cycle. Okay, these are the Tika cells. An overview, what are outline the principle of pathway as well as the hormones that are related to the Tika cells development. that are extended into androgen, estrogen, granular cells, as well as estrogen cells, and so on. So, okay, this is in more detail pictures. Okay, a more detailed picture from starting one day. Okay, every times that when you want to talk about menstrual cycle, make sure you are started from first day of menstrual cycle. First day of menstrual cycle. Okay, starting from day one, estrogen at the lowest level. Okay, estrogen at the lowest level. Hypothalamus are now starting to release gonadotropin releasing hormone. Okay. Once there, you know, okay, plasma hormone are now it's not too much, okay? It's always at the lowest level. The uterine wall are detached. Progesterone withdrawal because of the constriction of the arteries, necrosis and sloughing of the endometrium are occurring. From day 1 to 5, okay, please bear in mind from day 1 to 5, now they are starting to grow of the primary follicle. Start to grow of the primary follicle. Okay, what we call as menstrual phase. Now, from GnRH there, they stimulate the anterior pituitary and respond by increasing for the FSH. FSH there is two, okay, FSH there is crucial for development of follicle. That's why the name is follicular stimulating hormone. And then the increment of the follicular stimulating hormone and luteinizing hormone and ovary are respond by increasing the follicular growth. Okay, that's why they are follicular growth then. Then now it's after the day of 5, the ovary increase of Pica cells are increased. So means the follicle itself are growing. That's where the estrogen hormone are increased. Estrogen hormone are increased. Where do estrogen go? Estrogen will give signals to the GnRH to promote more production of LH and FSH. Okay, so this is where uterine men's phase will be ended. From day 6 to 14, if the mens are already there, uterus will respond to increased estrogen by generate a new vessel layer, means proliferative phase are there. New vessel layer, new vessel layer, new vessel layer means this become thickened again, arteries are developing again, and it is beginning of the proliferative phase. Follicle there. This is the follicular start to grow and release more estrogen and inhibin that inhibits the secretion of SH and LH. So during the day 14, anterior pituitary respond by releasing the built-up supply of SH, FSH, and FH. So now, during the day 14, LH increase very much rather than the amount of FSH. So the two sides respond by complete the first meiotic division. Okay, means high level of LH results in ovulation. Okay, now from day 14 to 28, from ovulation to 28, there Now here begin for the LH level. Will results the creation of focus lithium. The LH will develop, will have more in number rather than in FSH. Focus lithium will increase the production of estrogen and progesterone, will respond by entry into secretory phase, and increase progesterone and estrogen from focus lithium and negatively feedback to the anterior pituitary, which can decrease the amount of LH and FSH. Okay. From day 24, 25 to 28, the decrease of LH causes the decrease in the focus lithium. So focus lithium now become more smaller and degenerates into focus albicans and so on. Okay, in the day 28, first decrease in progesterone and estrogen, and the decrease of estrogen block all the production of LH and FSH. Decrease of progesterone cause endometrium to slough off, means this is the beginning of men's. Okay, menstrual cycle will begin and the cycle will begin again. This is all the endocrine, or what we call as hormonal control of ovarian cycle of ovulation. From high estrogen can cause LH surge and FSH surge. That spike that will cause the release of it is during ovulation. During ovulation, not during the mens. It's only for ovulation, but we do have inhibin, which are push down the FSH. FSH will be pushed down, and then the follicle development is decreased. This is another illustration on how, starting from uterine cycle on day 1, ovarian hormone, what are the hormone release, estrogen and progesterone, anterior pituitary hormone from LH and FSH. Starting FSH are more, then it start to LH to be keep on spike on the day of 14, and then you can see ovulation are occur then during the focus luteum and focus albicans development during the ovarian cycle. Menopause is characterized by cessation of ovarian activity over the years of 50-somethings, and the ovary, they are losing the response to gonadotropin to form FSH or LH, and then resulting from decline of the estrogen amount. Okay, LH and FSH are increased because of the lack of negative feedback, and ovaries itself deplete in the follicle. Estradiol and inhibin withdrawal. Okay, this is withdrawal effects of hormone. Okay, so what's happened to the body? They feel hot flashes, atrophy, and some vaginal and glands no longer produce lubrication, means it's such dry, feel dry and so on. After menopause, risk of atherosclerosis and osteoporosis are increased because of the hormone changes there. Estrogen is needed for bone deposition, so women at increase of osteoporosis. Okay, what we cause of the menopause transition is climacteric, is onset of menopause, which is what we call some of the symptoms, maybe 10 years before menopause. It's like some like irregular menses, mood changes, feeling easily irritated, loss of libido, hot flashes, and so on. And this is because the decrement in the oocyte number, decline in the number of follicles, and reduced responsiveness to gonadotropin. Okay. So what are happening? Before this, we have learned about this picture. Okay, the hormone interaction during the late climacteric. You can see decline or no follicles are less. So negative feedback of inhibin also less. Then it is decline the secretion of inhibin B. So what we call as climacteric reduced negative feedback. Then the elevated FSH level there rather than before. And then the salvage greater proportion of small follicles that cause enough small follicles still survive. And then adequate levels of inhibins and estrogen to rise also. And this is why late climacteric are approaching menopause, inhibin A and estrogen also will fall. Okay, this is all the inhibins A and estrogen level, which why the FSH level are elevated enough, as well as the LH level are elevated. Okay. Okay, then I think it is just now for the first part. We will learn again. We will continue again into a second part on what are happening inside the astrocycle for animal and so on. So stay tuned. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.